Okay, let's talk about the Charles law in diving medicine and in physics. We're talking about a law of gases. Let's talk about ideal gases, and we're talking about a state in which the pressure on the gas is constant, no change in pressure, and the amount of gas is also constant, no change in the number of molecules of the gas. In this situation, Charles' law states that the volume divided by the temperature of the gas is a constant value. You can see it like here. It's a constant value. So, for example, when you increase the temperature, in order for this value to be constant, you need also to increase the volume. And if you increase the volume, in order for that value to be V divided by T to be constant, you also need to increase the temperature. So if you increase one, you increase the second. If you decrease one, you need to decrease the second in order for this value, for this V divided by T to remain constant. This, for example, you can see in hot air balloons. If you have here a balloon, okay, and this is fire and this is the balloon. When you increase the temperature by using the fire of the gas, what will happen is that the molecule of the gas will expand, their volume will increase, and the balloon will become bigger. So this is an example of how increasing the temperature increase the volume, as Charles' law states. And it's a derivative of the ideal gas law. We'll see it in a minute. Remember that we are talking about the temperature in ideal gas law and their derivatives. We're talking about in kelvins, so you need to take the temperature if you have in Celsius and increase it by 273.15, which 273.15 in Kelvin is 0 in Celsius. This is the difference between Kelvin and Celsius. So, for example, in order to understand the relation to ideal gas law, this is the ideal gas law. Pressure times volume equals N, which is the number of molecules of the gas in moles, R, which is a constant, ideal gas law constant, and T is the temperature. So pressure, volume, nRT. PV equals nRT is the ideal gas law. Now, how we get to this Charles law? What we need to do is take this T, move it to here. The pressure will be constant, so you can just ignore it. The number of molecules of gas will be constant, so ignore it. And this R is constant, or you can see that the number of N is constant, R is constant, P is constant, so V divided by T equals, you can take everything constant to this side, you get V divided by T equals NR divided by P. And if all of this is constant, because you create those situations in which the pressure of the gas is constant, the number of molecules is constant, and the R is a constant. So if you know that the pressure is constant, so Charles' law dictates that V divided by T is a constant value. So again, it's a derivative of the ideal gas law in certain situations. And this is the Charles' law. Important in diving medicine, in physics, especially in relation to what happens when the temperature changes or when the volume changes. For example, if you, I don't know, doing a hyperbaric oxygen therapy, and no, this is not a good idea, good example. Okay, I show you the balloon, and this is enough. This is about the Charles' law. Thank you very much, and that's it. If there are any mistakes or correction, please tell me, and that's it.